we've just developed is a formula for the amount of money in some kind of account with a fixed annual interest rate, right? Where the interest is actually compounded once per year. So it's compound interest. But it turns out that there's nothing stopping us from compounding or calculating the interest more times per year. Again, when we talked about it once per year, it was every year we went and said, okay, well, it's the interest rate multiplied by how much was in the account the previous year, right? But we could do that more often. And we have a general formula for that. So if we're talking about compound interest here, and we're saying the amount of money in some kind of account with an interest rate R, so R is my annual interest rate, as usual, then it's going to be, in general, it's P, which is the principal, multiplied by 1 plus R over N to the NT, where N is the number of compounding periods per year. Okay, so the N is the number of compounding periods per year. Notice everything's done in terms of a year. T is also the number of years, okay, as usual. And P is principal. So this is the compound interest formula in general. And again, notice that we just came up with the case when n is 1. When n is equal to 1, in other words, we're only compounding once per year, we're calculating the interest one time per year, then we got this formula before. That is that A of t is equal to P times 1 plus R to the t. Right? This is what we came up before. But again, it turns out that if we want to compound more times per year, every time that we compound, it's called a compounding period, then we can do that as well. Okay? This is the more general formula for compound interest. And notice that if I'm computing interest more often, then we're taking the interest rate, the annual interest rate, and we're dividing it by how many times we're computing the interest, right? So maybe we're computing it 4 times per year. Well, we take your annual interest rate and divide it by 4, okay? And then, of course, we're adding on different parts each time, okay? So in other words, there's an n up here with multiplied by the t. So the way to derive this particular formula is very similar to what we derived before. The only difference is that we have more of these terms because we're compounding more times per year. You see that? Okay, if it's n times per year, we're going to have more of those multiplied by the principal. Okay? And so some common numbers for n that you see quite often are sometimes n is equal to 2, in which case we say it's compounded semi-annually. Okay, nothing surprising there. If n is 4, this is done a lot. Sometimes companies have quarterly reports, and so this is quarterly. If n is 12, this is another common number. This is when the interest is compounded monthly, right? So 12 would be how many months in the year. So this is monthly. And sometimes we have every single day. So 365 is daily. Okay? So these are some of the more common values of n, but of course n can be anything in general. And notice again that it's still some kind of exponential function where this is my base, and this is of course my exponent. The difference here is that n is usually a fixed number. Okay? In other words, if we're given a problem, we usually say at the very beginning that the interest is compounded n times per year. Okay? And so in general, this really is a function of t, whereby p, r, and n are all fixed values. T is the only thing that's really changing for how long we have the money in the account. Okay? So again, this is compound interest formula for the amount of money in some kind of account earning this amount of interest compounded n times per year. There's n compounding periods over n years. Okay? So that is the compound interest formula. So now let's do an application of compound interest. So suppose $5,000 was deposited into some account earning 3.5% annual interest rate compounded annually. The question is how much is earned after 1 year and after 2 years? So if this is compounded, notice it's compounded annually, which means once per year, so n is 1, and we have an interest rate as well, we know that we're dealing with compound interest. So in this case, the amount in the account after 1 year, okay, so T is 1 in this case, equals, it's the 5,000 again, which is my principal, multiplied by 1 plus it's 3.5%, so 0.035, okay? That's my interest rate per year. And it's going to be raised to the power of 1 after 1 year, okay? So this is exactly the same as simple interest if we had it. So if you multiply this out, you're going to get something like, of course it's all in units of dollars here. After 1 year, it's $5,175. The same as we talked about with simple interest. You'd get the same thing for simple interest, okay? But the amount in the account after 2 years, okay, this was 1, is going to be equal to 5,000 again, multiplied by 1 plus 0.035 squared, okay? We get the 2 here. And so when you put these together, 5,000 and this raised to the 2 power, you actually get, again, it's all in terms of dollars, you're going to get, and you should check that this is true, you're going to get $5,356.13. Okay? So this is more than you would earn if you had simple interest, if that was the only thing we're earning. Okay? So again, I'm just using the formula. And notice that the interest here is, it's going to be principal, which is the amount that we started with, plus some kind of interest on this, right? And in this case, we had the same thing, except we have an extra term because we have this squared bit here. Okay? And the extra term is the interest earned on the previous step. Okay? And this is how we'd compute the compound interest. Again, it's compounded annually, so my n is 1. Okay? So in some sense, I'm dividing by 1. Dividing by 1. Okay, there's a 1 up here. All right, so again, here's an application of the amount of money in some kind of account where the interest is actually compounded annually, but it's compound interest.